Hello students, let's solve the next question now. The question is, find the intensity of a laser beam of 20 milliwatt power and having a diameter of 1.3 millimeter. Assume the intensity to be uniform across the beam. Though this problem involves a laser beam, it is a basic question in physics which is asking you to remember the expression, or which is asking you to remember the relationship between power as well as intensity. Now, what is power? As you already know, power is work done per unit time. Now, if we look at the SI units of this power, for work the SI unit is joules, for time it is seconds. So, I can write the units of power as joules per second, isn't it? Now, what is intensity? Intensity is nothing but the energy incident on a unit area in 1 second. Okay, like how much of energy is being incident on a unit area in 1 second. The area is 1 units and the time is also 1 second. So that leads us to the units. The units of intensity can be written as joules per meter square per second, isn't it? Now, if I combine power as well as intensity, if I check the relationship between power and intensity, you must have already guessed by now, which is intensity can be written as power over some area. That is, intensity is power per unit area. So that's the same equation that you have to use here. That's the same formula you're supposed to use here. Okay, now let's write the given first. What all is given? Find the intensity of laser beam. What are we supposed to find out? Intensity I of 20 milliwatt. That is, here I told you that the unit of power is joules per second. It is also called as watt, abbreviated as capital W. Okay. So, power equals 20 milliwatt and having a diameter of 1.3, that is D equals 1.3 millimeter. Now, let's convert the units here itself, that is 20 into 10 to the minus 3 watt. This will be 1.3 into 10 to the minus 3 meter. Now, what we require is area for our problem, right? That is power divided by area. Area can be written as pi r square. Why are we taking area as pi r square? We could have taken that as square also, right? Are we assuming that it is a circular area? No, it is necessarily a circular area because we are talking about the laser beam. A laser beam cannot be, square in shape, right? Obviously, it has to be circular. That's why we are taking circular area over here. Now, what is given is diameter. We are supposed to reduce that to radius, which is 1.3 into 10 to the minus 3 meter divided by 2. So, we are dividing diameter by 2 to get area. 0.65 into 10 to the minus 3 meter. Now, let's plug in the values in the formula. I equals P divided by pi r square, which is 20 into 10 to the minus 3 meter divided by pi is 3.14 multiplied by 0.65 into 10 to the minus 3 whole square. Solving this, we get 15.08. I have divided 20 and this and 0.65 squared. I have done only that. Some of the students struggle to write correct powers of tens. So I am breaking up the problem in this manner. That is, I take only the numerical values. I'll not include any of the powers at this stage. If I do 20 divided by 3.14 divided by 0.65 divided by 0.65, I get 15.08. We have not yet taken this 10 to the minus 3, right? And also in the denominator, we have 10 to the minus 3 whole to the power of 2. That becomes 10 to the power of minus 6. That is 15.08 times 10 to the minus 3 plus 6 will give you, if this goes up, it becomes 10 to the plus 6, right? So that becomes 10 to the 3. Unit is watt per meter square. As I told you again, joules per second is watt per meter square. So joules per meter square per second is as good as watt per meter square. This is capital W. Alright, so the intensity that we have got is 15.08 into 10 to the 3 watt per meter square. Usually physicists like to express the units of intensity in kilowatts. So let's write it in terms of 15.08 kilowatt per meter square. So this is the right answer.